Hello everyone, my name is Alexander Zelenin.
Hi, my name is Alex Haletsky.
Today we will solve the last problem related to dictionaries and hash maps on Hackerrank. It's not the last problem related to this, it's last problem in this section. So if you want to read, just set on pause and take a look, and I will explain it by my own. We have array of numbers, and we have some additional number that is multiplier for other ones, and we need to find the count of pairs. No, not the pairs, triplets, count of triplets that reflect next rule. Like we starting with the first number, with any number, then we multiply this number by our number that we are getting in the second argument and multiply it one more time. So for example, if we have 1, we were looking for 4 and for 16. So if we have such combination, then we have one additional combination. If we have 4, 16, 64, it's another combination. For example, if we will have something like 1, 1, 4, 16, it will be already two combinations, because we can start with with the first one or with the second one and then go with another numbers. So what constraints we have here? Totally we have up to 100,000 of numbers, and each number up to 1 billion. Sorry, the second argument, which is right here, is up to 1 billion. So it's possible to multiply to this billion 2 times. So it will be 10 in 18 power. And every number is up to 1 billion also. So output format is count of triplets. So we will need to count all the triplets. So here is example. We have 5 integers and we have ratio of 5. So we're starting with 1 and we will need to find 5 and 25. We have two of such combination, 1, 5, 25. 1, another 5, 25. Okay? And two another combinations. 5, 25, 125. Another 5, 25, 125. So we have total 4 combination. How you think we can solve this task?
I'm sorry, I've just opened our stream in another window and a little bit lost. I think, first of all, we should compare each numbers in every array.
So
Every array.
we
First,
we have just one array, one line of numbers, like 1, 5, 5, 25, 125. With what we will start? Like for example, we go through this array and we start with 1.
Well, then I did not understand. I didn't understand the whole problem. We just have one array.
Yes, like this.
So, and what should we do?
We have another number that represent a ratio. And for example, we're starting with 1, and we will need, if we have after this one numbers like 5 and 25, and if we can make combination like 1, 5, 25, it's
Yes, I
count
understand.
as combination.
For example, if we have rate 4, then
Yes.
we should our result should be 4, 20, 20, 100, and etc.
No, 4, 16, and 40, 64. Like we multiply by this number. If we start with 4, then it will be 1, 4, and 16. We have this example exactly at start. So like 1, 4, and 16. If ratio is 4. I want to try to draw a bit, so I prepare the paint here to be paint warrior. So, for example, we have numbers 1, 4, 16, 1, 4, 16, and 46. 46. So, we need to find combination that the first number multiplied by 4 2 times. So that means that initially it multiplied by 4, the first number, and by 16. So like this. So 1 multiplied by 4 will equal to 4. 1 multiplied by 16 will be 16. So we are looking for combination like 1, 4, 16. And we have such combination here. Like 1, 4, 16. Okay. And then we go to next element. We have 4 here. 4 multiplied by 4 will be 16. 4 multiplied by 16 will be 64. So we have another combination here. So we totally have 2 combinations. One start with 1 and second start with 4. Let's take a look a bit further. For example, we going to the next element and we have 16 here. 16 multiplied by 4 will be 64. So, but if we multiply 16 by 16, we doesn't have another element here. So we cannot make another combination. Let's go with another example again. 1, 5, 5, 25, 125. 1, 5, 5, 25, 125. And we multiply by 5 and multiply by 25. So like we multiply by square of our number. So first our number is like multiplied by 1, second one by 5, and the third one by 25. So if we start with 1, the second one will be 5, and the third one will be 25. So from this point, from 1, we are going to next number. We see 5, everything is fine. Then we go for 25. We're going here. We had found this 25. We make a combination. Then, after this, we again go from 1 and go to next 5. Since we already use this one, we cannot use this in like this combination again. And we use 25 again. So we have 2 combinations starting with 1. Okay? Then we can start with 5. Like it will be 5, 25, 125. So we have combination like this. So 1, 5, 125. And we have another combination like this, starting with another 5 number. So it will be like this. So totally we have 4 combinations.
This is very complicated for me.
Okay, if you want, I can solve it by myself and just explain what it should be done here.
I really, when I read this problem, I really understand it in another way. So
Okay. Okay, so it's possible to return numbers here. Yes, it's possible. So the first super simple idea how it's possible to solve such problems is where we will going through our array. Let me just separate our numbers, because I use one color and it's a bit hard to understand where numbers start and so on. So we will go through our array and we will start with the first number, and we will calculate what numbers we need to find after this one. We will need to find 5 and then 25. So we see what number should be next, and we starting again from like this point. So we will not go to the left, we always will go to the right. So we will start with this point and looking for the 5. So we are find this 5, and after we found this 5, we will looking for 25 for the rest of the numbers. So like this. Okay. So we are going through internal array until we will found 25. When we found 25, we increase our counter by 1. So that means that we complete our combination. And also we can go until end of the array by trying to find another 25 number, because every 25 will give +1 to us. After this, we will return to 1 second. We return to this 5 I already had used for finding this one. So we will starting with this one. Okay, we already have +1 for one combination. We're starting with the next one, and we will searching in this part for 25. We again find another 25 and we'll make a +1. Okay. So we have totally +2. There is no another 5, so we will not start our chain again. So for one we at the end have 2 combination. Let's start with 1. Then we are starting with 5. We are calculating the next number, which will be 25 and 125. So we are start looking for this number in the rest numbers. We are finding 25 and start looking in the rest of array for 125. We will found it, so we make +1. So for this 5, we have another 1 combination. Then we go to the next element. We again calculate that we need to find 25 and 125 and do totally same thing. So we find 25, we find 125, and we make +1. After all of this, we have our counter of 4. What is the problem with this approach? So it is the simplest approach that is possible, that easy to understand and easy to implement. The problem with that approach, first of all, it doesn't use dictionaries, and when we are trying to solve problems that are under dictionaries in hash maps, it's like a hint, like it's a suggestion. Use this to make optimal. So with this approach, we doesn't use anything like that. We just go through an array, and that's all. So the main problem that on every step we will make like 1 second. On every step, for example, for 1, we will need to go to the rest of array. And like in worst case, every time on every step, we will need to go to the rest of array. So like, first of all, we need to go n times. Through n elements, n times. For every element, we also go through all array, which also n. And for like every other element, we also go through like internal array for n times. So by itself, this algorithm is like n cube at least, or yeah, since we are not looking, since it cannot go deeper than in than 2 times, then we have n cube total, which is like n square. Originally, I didn't pay it. I can write like this, which is a bit nicer. So my idea is next one. We will, of course, we will go through our array for the first time, and we will create a combination. So for every number will contribute to 3 objects. So like number, for example, number 25 in this example had contribute to combination that start with 1 and to combination that start with 5. Okay? I mean, we have 2 combination here, we have 1 here and 1 here. So this number had the contribute to both of these 5s, to this one. And if we will have like 625 here, it will contribute also to itself. So another combination will be like 25, 125, 625. So each number can contribute up to 3 other numbers, by 2 itself and 2 previous one. So we will have dictionary. Where we will start to start with the like combination start number. So in this we will have like 1, 5, 25, 125. Okay, yes. The bad thing that I cannot switch between the tools, so it doesn't matter. So when we find 1, so let me write down here, and we have multiplication by 5 and by 25. So we find 1, and we will try to divide it by 5 and by 25. If in any of steps it's like not an integer but will be like 0 something, So if we will have something after a comma, that means that it not contribute to this combination, because I presume that we're working only with fixed numbers. So 1 cannot be divided by 5 or by 25. So it will contribute only here. So for the 1, we will have another object. I will not explain what will be here, but first what we put here is 1. So I will explain this part a bit later. So we have like number 1. Like number 1 shows here just once. Then we go to number 5. So we are moving to the next element, to this one. 5 can be divided by 5. So 5 will also contribute to 1. So it will contribute to 2 numbers. First of all, let's add here like 1. We have 1, 5 here. And in the first step, we will have something like we need to split thing by stages. So we have totally 3 stages, like first number, second number, and third number, to create a combination. So this object will consist of 3 another one, 1, 2, and 3. Each of them will be an array. What? So, and for this array, initially we have like for the already forgot a bit what I want to do here, but no, I not forgot, sorry. This will be like array of objects, and for this we will have like 1, 1. It looks like 2, but it's 1. You need to believe me. I will try to write it better a bit. Okay, 1, 1. When we contributing 5 here, we will create the next stage, like the second stage. And on the second stage, we will copy everything from the first stage and we'll add 5 here. So we'll have like 1, 1, 5, 1. Okay? Mm-hmm. So it was on the second step. And it also create here like same object, but it will be like 5, 1. There's already no space, but okay, let me try. It will be like 5, 1, like this. So when we go to the next 5, it also contribute to 1 into 5. So first it contribute to 1. And we take a look that it should contribute to like first second step. So we are going to the second step, and we found that we already have like 5, 1. So we will increase this number to 2. So it will be like 5, 2. That means that after 1, we meet 5 2 times. Okay?
Mm-hmm.
Then the 5 will contribute also to itself. So here we will have like 5, 2. So like here we have 1, 1. We have here 5, 2. Like on the first stage, it will be 5, 2 for this object. Then we go to next number. We found 25. 25 can contribute to 5 and to 1, since it's divisible by both of them. So let's start with contributing to 1. Since it's like the third step, we're creating the third step and copying everything from here. So it will be the same object like we have above. And then we have 25, 1. Okay. It also contributes to 5. It sounds complicated because maybe it is complicated, or maybe it make overcomplicated by some reason and it's not proper solution. But anyway, let's go with this. So since we need to contribute 25 here, we will have like 5, 2, 25, 1. So it's like second stage for the number 5. Okay. Then we go to the next number. We have 125. 125 contribute to 25 and to 5. So first we are going to 5. And we make the third stage here. The third stage will be like 5, 2, 25, 1, and 125, also 1. Okay. After this, we are contributing also to 25, which will have only 2 stages, so I will not focus on this now. And for 125, we're also creating like 125, 1, the first stage. So, okay, we go through all our numbers, and we are creating some structure like this. Wow, what we can do with this? Like, we create something, so we need to do something with that. We can do next thing. We will go through our object, through every number. So first we go to 1. We go here. And we will take a look only for third step, because only third step consists full combinations like 1, 5, 25. We will what I doing? Okay, fine, everything. So we have totally 2 numbers with the third stage. It's number 1 and number 5. In number 1 we have 1, 1, 1, 5, 2, and 25, 1. For number 5 we have 5, 2, 25, 1, 125, 1. Okay. How we will count the combinations itself? So we have 3 numbers here, 1, 2, and 1. We will reduce this number by 1. So we will have, I will explain why a bit later. We'll have like 0, 1, and 0. Now we'll make sum of this number, which give us 1. And the count of combination will be 2 in 1. So it will be 2 combinations for them. Like if we have 1, 5, 25, it's 1 combination. 1, 5, 5, 25, it's like 2 combinations. Since we have 2 5s, like we can have 2 combinations. But if we have only 1 number, it can like lead only to one combination with this number itself. That's why we're reducing this number by 1 and making this like a power of the number. So if, for example, we will have 555 here, the count of combination will be not 2, but 4. Like every additional number increase count of combination by 2 times. Okay, so we do the same thing for the last one, which lead us to like 1 0 0. So we have another 2 combination. If we will have 1 1 1, it will be 2 powder 0, which lead us to like 1. So, and now we make sum of these numbers, which lead us to totally 4 combinations. Oh, okay, that's the algorithm. Like, what is the adventure of this algorithm with the previous one? Let's think of this. First of all, we're going through our array initially one time. So, like, we go through array one time. So we have O1 here to create this object. But inside we do some other operations, but like it's a fixed amount of operations of itself by itself. Maybe copying array in some cases will took some additional resources, but we will count this later in code how long it might take. And like later on, we also go through our object just once, which lead us again to just on. So it looks like ideally we will end up with the on algorithm, and we will store about another on memory, which is much better than on cube. It will be n square by algorithmic complexity, by time complexity, but generally I like this one. Looks much better than like n in cube, right?
Mm-hmm.
So we need to implement this. Let's try.
Let's try.
So we have like 2 steps here. The first step, originally we can like make 3 steps here. The first step is going through our initial array. Second step is filling stages. And the third step is going through our structure at the end and count the combinations. So let's rename R to a ratio, the number that we will need to multiply. Let's create our structure, and in the end we will need to return count of combinations. Count. Let's call it total count. Okay. So maybe we can split it to different functions just to make it a bit better. So let's create a function that will call the create structure that will receive array and a ratio. Then we will have another function to It will be used inside here. Something with stages. I will call it like this and will rename it later. Something with stages. I have no idea what it will return. And the last one that will count of combinations. Function count combinations that will receive our structure. Okay, let's start with the last one because it looks easiest for me, and it should be very fast, very easy to write.
Okay.
So we receive keys of our numbers and go through them. So we have like number here, like 1, 5, and so on. We are going inside and like we are going for 1, for example. The 1 will be another array. No, sorry, it will be an object. It will be an object with 3 stages, 1, 2, 3. We are looking for the stage number 3 only. And this stage is array of objects. So we'll go through this. First of all, we will need to check that this exists. Like if it not exists, we will need to return it here without doing anything. So if we have something for this number exists, of course, we need to check only the last stage that this exists. So we're going through every, how it calls, triplets, good name, triplet. We're going through our triplets, and for triplets we have like another 3 numbers. So triplet object case for each. So we are going through case, and here we have, let's call it like key. And we'll count the total. So we are counting this number right now. Sorry, we count this number right now. So we want to have something like this. We will increase total by triplet key, so -1, like this. And we will need to make something like math po 2 in total. So we're making the pointer, we're making this operation, and we found the count of combination here. Okay. What we need to do here? Let's create a count, and we will increase our count by this number, and we return count. Okay. That means that we doesn't need this total count. We will able only to call like count combination and pass our structure. Okay, like one of the steps is done. The lastest one. I hope it will give something to us. So Now the main thing is to create the structure itself. Just to want to explain a bit here in terms of complexity, like it looks like we have like a cycle inside of cycle inside of cycle and so on, but like here we always have 3 items, so it will be like O1 for this operation. For this operation we will have more more elements, but I will get back to this a bit later. So it also not so complicated. So we have create structure. What we have here, so we are going through our array for each. Let's do like this. Structure will be equal to create structure like this. So our original function will be only 2 strings, that's all. We are going through this and we will need to return structure itself. Okay. We have number, and this number can contribute up to 2 another numbers, like number divided to ratio and number divided to ratio, like this, and to itself. So we have like 3 places where we can place our number. Let's create a small array and call it contributions. Const contributions. Okay. Initially we will put the number itself here, because at least it contributes by itself to here. So, and we'll have the second one and the third one. Let me write it like this. So right now we can add just simple code, like to check is the like, do we have anything after comma? So if it equal to 0, like if we doesn't have anything after comma, then we we will add our second number here, and we do totally same with the third one. Maybe it's not super clean code, because we have some duplicated logic, but but not too much, and maybe we'll optimize later. For now it doesn't matter. So we have our contributions. Also, we need to mention to which step we contribute. So let's have an object here. So it will be array of objects. We'll have like stage 1. For the second number, it will be stage 2. Stage 2. Number second, and for the third one it will be like stage 3. Okay, now we go through our contributions and through our contribution. We have maximum 3 of them. He already tired of this. I understand.
Mm-hmm.
And we have stage and number. So then bad thing here that I already use number here and we have number inside. Let's call it base number then. Like base number. Okay. So we'll be able to have another variable and they will be not the same. So we have, we go through our contributions. Oh, we have stage and number. We found that this number exists in our structure, or if stage is or if the stage is the first one. So maybe we can just to check if the stage is first, and that's all. Okay. So let's starting with this. If we have first stage, we will take the not the contribution, sorry, structure, number. We have this structure, we're getting this number, which should lead us to object with up to 3 keys. We have this number and we will like use this or create a new object with stage number 1. And this stage will have an array like this. Then for every element of the first stage we will have always only one stage for only one element for the first stage. So we will increase we're also getting the first element of the array. We always will have only one element of array here. And for this element, we getting our number and increase this by 1. So it equal itself or 0 plus 1. It looks like very large one. So we are like going here and getting the first element of the... One second. I need to rewrite it a bit, otherwise it's already looks like not as good. Like for the first element should be equal to itself or to object with our number like this. Oh, I presume that maybe I using some wrong algorithm for this task, as this is like a medium task and not the hard one. So maybe I'm making it overcomplicated. But okay, so I mean it's not okay, but we'll see. So if we have stage 2, then we will need to find 1 second. If we have stage 2, then we need to check that stage 1 is exist for this number. And if stage 1 doesn't exist, we will not contribute to stage 2 at all. So we are checking that this number exists and in our structure, and that stage 1 is also exist for this number. And let me write for stage 3 right now also. So for stage 3 it will be the same, but we will checking for the stage 2. Like, we cannot contribute to the next stage until the previous one is exist. So to contribute to stage 2, first what we will do is to try to find that the stage 2 1 second. I just need to think for a second. So we are taking this number and the stage 1, we are sure that this it exists. So we will going for the second stage, and it will be equal to the second stage or to the copy of previous stage. Yep, or to the copy. So copy stage like this. So we need additional function that we will call copy stage. If it took too long for today, we can continue tomorrow if you want.
It's better than continue right now.
Okay, then let me just finish the copy stage 1 and or I can just leave a comments. So copy all data to like make a clone of provided stage. Okay, I think let's continue with this task tomorrow and finalize our code. I think generally we have already like our algorithm that should work, but maybe not as good. I will think a bit more about this, but we generally will implement everything like it was described initially. Okay, thank you for today. Have a nice day.
Thank you for exploration. Goodbye.